Hi, this is Naveena and my upcoming video is nothing but the introduction to data link layer, and I am from the Department of Cybersecurity in the Institute of Aeronautical Engineering, Dundigal. So today I want to discuss the introduction about the data link layer in this video. First of all, in this we need to discuss the topics, the introduction to data link layer and the internets and its combinations and the services provided by the data link layer, and so the sublayers of the data link layer and the link layer addressing, the three type of addresses which should be present at the data link layer, and the address resolution protocol, the error detection and correction, and the redundancy. So some of the topics I want to discuss by means of this video. So first of all, regarding the introduction to data link layer, the first node is the source node, the last node is the destination node, or else if you want to discuss the data link layer, the transport in the data link layer is nothing but the node to node. That means the one node we should be considered as a source host, the last node is considered as a destination host. If you want to take the example of one diagram, suppose if it is by means of, if you can take the example of one source node and the destination node, and in between there are some nodes, if you can identify 1, 2, 3, 4, 5, 6. In this there are links L1, L2, L3, L4 and L5. So the link number 1, 3 and 5 will be considered as the LANs, and 2 and 4 will be considered as the WANs. So I want to discuss and I want to define what is the type of transportation we have to see under the data link layer is nothing but every physical link must be consist of two types of nodes. The first one is meant for the source node, second one is the destination node, and here we have to identify there should be a physical path which should be the link between the source and the destination connecting with n number of nodes. This what we can call it as a nodes and having with many links. So if you can take the example of this given figure, the node 1, node 2, node 3 will be connected by means of a LAN, so if you can assume it, and node number 2 and node number 4 will be considered as a WANs. So the first, the third and the fifth links present 3 LANs. The second and the fourth links will be present the 2 WANs. Here the duty scope of the data link layer is node to node. Here we have to see the mode of transmutation is by means of a data frames under the data link layer. And that type of transmission of data packets, here we have to identify from one node to the another node. When a packet is traveling in the internet under the mode of data link layer of a node from a host or a router, it is responsible for delivering a data packet or datagram to the next node in the path. So for this purpose, the data link layer of the sending node needs to encapsulate the datagram received from the network in a frame, and the data link layer of the receiving node needs to decapsulate the datagram from the frame. Here we have to identify the two types of terms. The first one is the encapsulate, the second one is the decapsulate. What do you mean by encapsulate? Encapsulate is present at the source node. If you can take the example again, the encapsulation will be present at the source node. And destination host, it will be converted by means of a decrypted mode or decapsulated mode. What do you mean by encapsulation? And the conversion of the plain text into a cipher text is nothing but the encapsulation, or the decryption means, or decapsulation is nothing but the conversion of a cipher text into a plain text. It is nothing but the decapsulation. So under the mode of or the data link layer, and under the process of data link layer or the services provided by the data link layer is nothing but the encapsulation, the text into the decapsulation. The source code will need to enter the passes or the type of message by means of encapsulated mode, and whenever it reaches the destination, it will be transmitted into the decapsulation mode. Again, From the destination host, the decapsulated data can able to transmit it to the source by means of a encapsulated mode. In other words, the data link layer of the source host needs only to encapsulate. The data link layer of the destination host needs to decapsulate. But each intermediate node needs to both encapsulate and decapsulate. We can list out the services provided by the data link layer in the coming section. So coming to that one, the internet here is a combination of networks which should be combined together by connecting devices, what we can call it as a routers or switches. If a packet, it can able to travel from one host to the another host, it needs to pass through these type of networks, whether that type of networks may be by means of a routers or switches. So communication at the data link layer is made up of 5 separate logical connections between the data link layers in the path. So here the most important elements which should be present under the data link layer is nothing but the nodes and the links. So communication at the data link layer is, as I already explained and discussed before the starting of this video, it should be by means of a node to node. A data unit from one point to the internet needs to pass through many networks. Those networks by means of either by means of a LANs or a WANs to reach the another point or the destination host. So these LANs and WANs are connected by means of the source nodes, what we can call it as a routers. So it is customary to refer the two ends of a two hosts and the routers as nodes and the networks in between as links. It is a simple representation of links and the nodes. Then the path of a data unit is only having the 6 type of nodes. So up to that, we have to see that what is the type of data transmission and how the data transmission will take place under the data link layer. Here, the mode of transportation is by means of a data frames which should be from node to node point under if you have discussed about the data link layer. So coming to the services provided by the data link layer. So the first one is the framing, flow control and error control and congestion control. Nothing but that if you want to discuss the first services which should be provided by the data link layer is nothing but the data link layer at each node needs to encapsulate the datagram. What we call it as a datagram, if you can define, it is nothing but a packet. A datagram is a unit of data which should be in the form of a packet received from the network layer. So in a frame, before sending it to the next node, the node also need to decapsulate the datagram from the frame received on the logical channel which it meant for the transportation. So coming to that, the second services which should be provided by the data link layer is nothing but the flow control. The sending data link layer at the end of the link is a producer of the frames. The receiving data link layer at the other end of a link, what we can call it as a consumer. The first one is the producer. That producer, what we can call it as either it will be a sender or a source host. The other one is a consumer or destination host. If the rate of a produced frames is higher than the rate of a consumed frames, the frames at the receiving end needs to be buffered while waiting to be consumed or need to be processed. Definitely, we cannot have an unlimited buffer size at the receiving side. We have two choices. The first choice is to let the first one is the either by means of a receiving data link layer from the drop of the frames if the buffer is full of traffic only, or to create a frame. And the third services which can be provided by the data link layer is nothing but the congestion control. So although a link may be congested with frames which may be results in either by means of a discarded the frame or frame lossing, or most data link layer protocols do not directly use a congestion control to elevate the congestion, although some WANs or LAN works can able to do it. In general, the congestion control is considered an issue in the network layer or the transport layer because of its end-to-end point nature. So if the next topic which should be discussed under the data link layer is nothing but the sublayers of data link layer. Here we have to identify the two types of sublayers. The first one is to better understand the functionality and the services which should be provided by the data link layer. We can divide the data link layer into two sublayers. The first one is the DLC. Data link layer can be divided into two types. The first one is the DLC, data control link, and MAC, medium access control layer. So these are the two sublayers of data link layer. What we can call it as, the first one is the DLC, data link control. Second one is the medium access control. The data link control sublayers deals with all issues common to both point-to-point and broadcast links. So coming to that, the second one is the medium access control sublayer deals only with issues specific to the broadcast link which should be present under the physical layer, what we can call it as the transmission media. So coming to the link layer addressing. A link layer address is sometimes called as a link addresses, or sometimes it may be identified by means of two types of addresses. The first one is the physical address, second one is the MAC address. Sometimes a physical address we need to identify, and sometimes a MAC addresses. Since a link is controlled at the data link layer, the addresses need to belong to the data link layer. So when a data packet or a datagram need to passes from one network layer to the data network layer, the datagram will be encapsulated in a frame and two data link addresses are added to the frame header. The frame header consisting of one IP address. Each and every data packet, which type of format they need to transmit from or they want to transport from one source to the destination, every data packet or a data unit or a datagram or a data bit consisting of one IP address followed by a one number to reach their successive destination. So hence, what is the use of link layer addressing is these two type of addresses what we have defined already, the physical address and MAC address, are changed every time the frame moves from one link to the another link. Here again we have to identify the three type of addresses. The first one is the some link layer protocols define the three type of addresses. What are the three type of addresses means? The first one is the unicast, second one is the multicast, third one is the broadcast. So coming to the link type of addresses, the three type of addresses we should be hold by means of a data link layer is nothing but the first one is the unicast address. So each host or each interface of a router is assigned to one type of single or unique address, what we can call it as a unicast address. Unicasting means one-to-one way of communication we might be identified under the data link layer. So coming to that, the second one is multicast address. So some link layer protocols define multicast addresses. That means multicasting means one to many type of communication. That means from one source to the many destination, they need to pass the data packets or datagrams from one source to many destination. That is the meaning of multicast addresses. So coming to that, the last and least one is nothing but the broadcast address. Some link layers define a broadcast address. Broadcasting means one-to-all communication. That means a frame with a destination broadcast address is sent to all entities in the link. That means whatever the entities are the destination, one link it might be consisting based on the source and destination. That type of links must have a need to get this type of broadcast addressing from based on that nodes present from one link to the another link. So if you can define the broadcast address means, the broadcast address means it is one-to-all communication to all entities which should be sent in the link. So coming to that, the next element of a data link layer is nothing but the address resolution protocol, ARP. So anytime a node has an IP datagram to send another node in a link, it has the IP addresses of the receiving node. The source host knows the IP address of a default router. So each router except the last one in the path gets the IP address of the next router by using its forwarding table. The last router knows the IP address of the destination host. So again, and I want to discuss in our previous topics under the data link layer, I have already explained every data packet or a data frame or a data bit, it will be holding some IP address as well as the IP number whenever it is ready to transmit from one source to the another destination host. So like that only, however, the IP address of the next node is not helpful in moving a frame through a link. We need the link layer of the address of the next node. This is the time when the address resolution protocol becomes helpful. So coming to the next point of a ARPR, what you can call it as the address resolution protocol, is one of the auxiliary protocols defined in the network layer and which we have to see and identify in the data link layer only as well as the network layer only. It belongs to the network layer, but we have discussed it here because it maps an IP addresses to a logical link address. The ARP accepts an IP address from the IP protocol, maps the addresses to the corresponding link layer address and passes it to the data link layer. So what is the main task performed by the address resolution protocol means, suppose if you can take the example of one data frame under the data link layer and it will be ready to transmit from starting from a one source to the another destination. So that packet definitely might have a need to hold one IP address. That what you can call it as a IP number also. So whenever the source consisting of n number of data packets to transmit from one source to the another destination host, if it will be flowing continuously, starting the transmission from the source host continuously to the destination host. Suppose in the middle, any type of data frame or any type of data bit, it will be having any discarded or does not hold any IP address, or it will be having any error while transmitting the data frames to the destination from one source to the destination. So the source node only may be identified that this type of that n number of data bits or data frames I need to transmit to the destination. Thus what the source node might be having thinking means that it will be having the starting of the only 10 number of or n number of packets, it will be transmitted from one source to the destination. But at the destination host, it may not be having any intimation whether that type of n number of hosts will reach it to the destination in a successive mode or not. Why? Because in the middle, any packet will be discarded or any error it will be occurred whether that packet holding the IP address or does not hold. That type of packets will be discarded in the middle and it will be sending to the source host, again retransmitted to the source host, and the source router may be defined and redefined, and again it will be implemented and it will be tried to send those packets, whatever the error it might be occurred there, it will be checked at the source route and it will be again need to send to the destination host. So whenever, and as I am telling, each and every packet must hold one address. If that address is having the source host and the destination host, one packet it will be ready to transmit from a source host, definitely it will have some certain address to reach the destination host. Until unless it does not gets or does not having any destination address, and it will be very difficult to reach in a successive destination host. So for that only, so address resolution protocol is useful or is helpful under the data link layer for the transmission of packets means the type of the mode of help, it will be done by means of a data link layer, by means of address resolution protocol under the data link layer is nothing but to identify whether each and every data packet we should be travel from one source to the another destination host under the data link layer holding the address or not. This is the type of role performed by means of a address resolution protocol under the data link layer. So coming to the next important element which should be present under the data link layer is nothing but the ARP packet. The names of the fields are self-explanatory. The hardware type field defines the type of the link layer protocol. So Ethernet is given the type 1 and the protocol type field defines the network layer protocol, and The IPv4 protocol is 080016. The source hardware and the source protocol addresses are variable length fields defining the link layer and the network layer addresses of the sender. Suppose if you have shown the given figure by means of a ARP packet format explanation, the first or the hardware type we should be under by means of a 16-bit, and besides that one, the protocol type we should be having P type and the 16-bit, and next one, the hardware length, we should be commonly call it as a HLEN, protocol length PLEN, operational request, the first mode, it is the type of reply to of 2. So here under the sender hardware address, if you can elaborate it, or in shortcut form we can call it as a SHA. Under that one, the sender protocol address is SPA, target hardware addresses are THA, and target protocol address is TPA. So here the destination hardware address and the destination protocol address fields define the receiver link layer and the network layer of the concerned addresses. An ARP packet is encapsulated directly into a data link layer, and the frame needs to have a field to show that the payload belongs to the ARP and not to the network layer datagram. So the next element we should be coming under the data link layer is nothing but the error detection and correction. So error detection and correction, this is the most important thing. Why? Because if one source is ready to transmit the data packets under the data link layer, there should be discarding or any error oriented packets need to transmit from one source to the another destination. That type of error packets will detected and corrected, and again it will be retransmitted to the source, and then it will be checked by the source host, and again it needs to retransmit in a successive mode to the destination host. So here, what do you mean by error detection and correction means the checking of the errors, identifying the errors are nothing but the error detection, and correcting of those errors, and again retransmits those errors to the source host, and again it will be transmitted in a successive mode until and unless it reaches the destination host is nothing but the error detection and correction mode. So here the networks must be able to transfer data from one device to the another with acceptable accuracy. For the most seen applications, a system must guarantee that the data received are identical to the data transmitted. Again, anytime the data should be transmitted from one node to the another node can become corrupted in the middle under any circumstances. So, many factors which should be included or influenced can alter one or more bits of a message. Some applications require a mechanism for detecting and correcting the errors while you are working with data link layer. So, some applications can tolerate a small level of error. For example, random errors in audio or video transmission may be tolerable, but when we transfer the text, we expect a very high level of accuracy mode of transmission, and we are working with the transmission levels of audio or video level. So at the data link layer, or if you can discuss about the data link layer, if a frame is corrupted between the two types of nodes, it needs to be corrected before it continues its journey to the successive destination path. However, the most link layer protocols simply discarded and let the upper layer protocols handles the retransmission of the frames. Some multimedia applications, however, they try to make the solution to corrupt the corrupted frame. So here, coming to the next topic under, or the next primary element, important element under the data link layer is nothing but the single bit error and burst error. So here, under the last two layers of the OSI reference model, we have to identify the last one is the physical layer, and data link layer is present in between the network layer and the physical layer. That means the services, the data link layer provides the services to the upper layer, what we can call it as a network layer, as well as it will consumes the services from the below layer, what we can call it as a physical layer. So whenever the type of data under the data link layer is, the mode of transmission is by means of a data frames. So whenever a data frames or in other definition or in another way, we can talk it or we can define it in the mode of a data bits also. Whenever the flow of bits from one point to another point or from one node to the another node, that is subject to unpredictable changes because of the interference of any error detected packets. It might be included while traveling the successive point of messages from one point to the another point. This interference can change the shape of the signal. The term the single bit error means that only one bit of a given data unit, such as it may be by means of a byte, a character or a packet, is changed from the type of bit can be transmitted from 1 to 0 or 0 to 1. The term burst means the two or more bits in the data unit have changed from 1 to 0 or 0 to 1. So most effectively, under the figure 2.3 shows the effect of a burst error on a data unit. Let us see what is the type of the example it should be showing. A burst error is more likely to occur than a single bit error because the duration of the noise signal is normally longer than the duration of a one bit, which means then when noise affects data, it affects a sets of bits immediately. So again, and I have diagrammatically, this is the diagrammatical representation of single bit error. A single bit error means only one bit of data unit is changed from either 1 to 0 or 0 to 1 according to the shown in the figure given below. So here, if you can identify the single bit error, so here we have to identify the 0, 0, 1, 0, 0, 1, 1, 1. This is the data sent from one source host to the destination host. Again, at the destination side, 0, 0, 1, 0, 0, and this one will be changed or converted into the by means of a 0. The one will be converted or changed by means of a 0 bit, and again it will be same like 1 to 1, and again this will be 0 to 0 whenever we have to identify at the destination host. So here this is the one of the example of a exemplary model of a single bit error. That means simply single bit error means the data it will be converted from either 1 to 0 or 0 to 1 according to the figure I have already explained. And here the number of bits which will be affected depends on the data rate and duration of noise. For example, if you are sending a data at 1 kbps of noise, 1 by 100 second can affect 10 bits at a time. If you are sending a data at 1 mbps, the same noise can able to affect 10,000 bits. So coming to that, the next concept under the data link layer and the most primary concept or important concept is nothing but the redundancy. The central concept in detecting our errors correction is nothing but the redundancy. To be able to detect the correcting errors, we need to send some extra bits with our sending data. So these redundant bits are added by means of a sender and removed by means of a receiver. Their presence allows the receiver to detect the corrupted bits, detection, viruses, and correct them and send them again in a continuous flow. So the correction of errors is more difficult than the detection. In error detection, we are only looking to see if any error has occurred or identified, while there should be identify some flow from one source to the destination host. The answer is a simple yes or no. So we have not seen interested in the number of corrupted bits. A single type of bit error is same for us as a burst error. So again, in the second point, in error correction, we need to know the exact number of bits that are corrupted, and more importantly, their location in the message, the number of errors and the size of the messages which should be transmitted from one sender to the receiver under the important factors. So coming to that, the next error is nothing but the burst error. A burst error means two or more bits in data are changed either from 1 to 0 or 0 to 1 as shown in figure. But comparatively, if you can define what makes the difference between a single bit error and burst error, means in burst error, it is not at all necessary that only consecutive bits are only changed. Not all the bits, no need of changing again and again, only the set of consecutive bits can able to change. The length of the burst error is measured from first changed bit to last changed bit according to the figure given below. So again, I want to describe the figure based on the pictorial description. Again, we have to identify the number of bits which will be sent from one source to the destination. The data sent from a one source, if you can take it in a consecutive bits way, like 1 0 1 0 0 1 1 1 0 0 1 1 0 1 0 1. This is the type of data sent from one source node or from one source host. So again, this is the type of data which should be received by means of a destination node. That means 1 0 1 0 0, again 0 1 1 1 0 1 0 0 1 0 1. So in the middle, so the data sent, it should be having in the consecutive bits. Again, it will be received in the consecutive mode only. What makes the difference between while sending the data from one source node to the destination nodes means a byte changed by the burst error. This is one of the exemplary how a byte will be changed while transmits or while traveling from one source node to the destination nodes. Here we have to identify the 1 will be changed by like a 0 and the 0 will change as a 1. Again, the 1 will be changed as a 0 and the 0 will be again changed as a 0. So, we have to identify simply the conversion of 1 to 0 and 0 to 1 under the burst error while we are discussing under the data link layout. So, coming to the last point, in error correction, we need to know the exact number of the bits which should be corrected, one, and more importantly, the location of the message. That means when the corrupted bit will be while transmitting the data, whether it will be in the middle or starting of the source or at the end of the destination node, we need to identify the location of a one data bit or data unit when it will be transmitted or start to travel from one source to the another destination. The number of errors and the size of the messages are the very important factors to determine the error detection and correction coding while we are working with burst errors and single bit error. Thank you for watching this video and please keep watching the upcoming videos. Thank you one and all. Naveena.
Like, share and subscribe. Hit the bell icon for more updates.